So hello everyone and welcome back to SWEcodes. So this video is again in continuation to the binary search series, and we have another medium lead code medium problem, that is search in rotated sorted array. So let's try to give a read about this question. What does this question says? So there is an integer array nums that is sorted in ascending order with distinct values. Okay, yeah, it's clear. But prior to being passed to your function, nums is possibly rotated at unknown pivot index. We know what a rotated sorted array means. We already have seen that in previous video. So if you don't have watched previous video yet, just go watch previous video before continuing to this problem. Okay, so it might be possible that our original array should be rotated. So we are given that array after the possible rotation and a target. Yeah, so we need to search for the target in that sorted rotated array, and if it is present in the nums, we'll have to return the index, otherwise we'll have to return -1. So let's try to analyze this problem here. So what we'll have is, like, we have something like 4 5 6 7 0 1 2 3, and suppose your target is, suppose my target is 5. Suppose my target is 5. So if you try to write a condition directly with this target on this condition, because it is sorted and rotated array, and if you try to write the similar condition that we have for the binary search, that is x greater than equals to target, let's try to write it. So x greater than equals to target, that means this will return true, this will return true, this will return true, and everything else will return false. If you will see, if you apply directly this conditions array, if you will apply binary search on this conditions array, so this conditions array is not sorted, just doesn't look sorted, because we have false, then we have some trues, then we have some false. This is not looking sorted, so I cannot apply directly binary search here. But if you think carefully and if you look closely, if I can imagine my array to start from here and go circularly till here, then I can guarantee that we'll have series of false values, then I have series of true values. I just need to find the first true value. You see, since it is sorted and rotated, so if you start from the minimum element and go looking for the element in circular direction, then binary search can be applied, because we have series of false values, then we have series of true values, and we can use this condition x greater than equals to target. We can use this condition because we need to find the target, and the first true value will give us target, and if it is not there, we'll just have a check, like the first true value is equals to target or not. If it's equals to target, we'll return that index, otherwise we'll return -1. So how will you start looking from this position? How to start looking from this position? So I'll just do one thing. Okay, let's try to analyze this again. What I'll do something like 4 5 6 7 0 1 2 3. Suppose our original array was 0 1 2 3 4 5 6 7. Let's initialize low and high values in both the arrays. So this is our low values, this is our high values, this is our low value here, and this is our high value here, and our target is 5. We know our target is 5. So in this array, what are the conditions? Conditions are all these elements are less than the target. Yeah, all these elements are less than the target, and here on we'll have true values. Similarly, here we'll have something like this. So let's try to do binary search on this array. Let's assume the array is sorted, and we'll analyze how we can achieve the same with this array. We'll analyze. So your mid will be, will be your mid? Your mid will be something like here. Similarly, in this case, your mid will be here. Okay. So if you will see carefully, if array was sorted but not rotated, then our actual mid was 3. But here we are getting our mid as 7. So how we can get our mid as 3. Our actual mid should have been this. Our actual mid should have been this. This is our actual mid. This is our actual mid. And this is the mid that we are getting. You see, this is the mid that we are getting. So if you see carefully, this 3 is how many places greater than 7? If you see carefully, this is 1, 2, 3, 4. So what we have to do is like we have to go look 4 places ahead than this mid for the actual mid. You see, and suppose I'll do some more analysis on this. So we'll need a larger space. So we'll do some more analysis. So our original array is something like 1 0 1 2 3 4 5 6 7. Then we have our then we have our 4 5 6 7 0 1 2 3. This is the actual array provided. This is, we are assuming, if it would have been sorted but not rotated. So these were the low value, these were the high value, and this was the mid calculated. And this is the low value here, and this is the high value here, and this was the mid calculated. But this is not the actual mid. The actual mid in the sorted array would be 3. This is the actual mid. Suppose let's try to do the binary search in this sorted array. So our target was 5. We know our target was 5. So since this 3 is less than 5, then all these elements or these elements are also less than 5. Then what generally we do? We do low equals to mid plus 1. We ignore all this half. And we'll do low equals to mid plus 1. Our low would be here. Similarly, you increase your low to be here in this case also. Similarly, we will increase the low to be here, mid plus 1. Now let's try to analyze what would be your mid. Your mid would be something here. Similarly, your mid would be something here now. But if you see carefully, now the mid is 5. But in the sorted rotated array, we are getting mid as 1. So how we can get 5? So if we'll go 4 places ahead, 1, like 1, 2, then since it is circularly sorted and rotated, then this is the 4 and this is the, this is 1 place, then 2, then this is the 3 place, and this is the 4th one. So see, this is the actual mid. And since it is true, we'll do high equals to mid. Similarly, do high equals to mid here. Your low was here. Similarly, do high equals to mid here. Not do high equals to actual mid, just do high equals to mid here. High equals to mid here. Now we'll calculate again. Then our mid comes out to be similar to the low. Similarly, here our mid is also pointing to the low. If you'll see carefully, our mid in the original sorted array is pointing to 4, but here our mid is pointing to 0. And how we can get that 4? We'll have to go 4 places ahead. So this is 1, this is 2, this is 3, and this is 4. So we can get our actual mid. By looking 4 places ahead than this mid. So since it is false, we'll do low equals to mid plus 1, and now low and high will point to this same value. So I'll do the different color. Now low and high, this is low, this is high, will point to this same element, this 5, and this is our answer. Similarly, if you will do low equals to mid plus 1, your low and high would point to this one. But this is not the answer. For the actual answer, you'll have to go 4 places ahead, like 1, 2, then 3, then 4. So this is our answer. So you see, it's very simple. And why I am looking for 4 places ahead? You have any idea why I am looking for 4 places ahead while calculating actual mid? Why I am taking 4 places ahead from this mid? Because the array is rotated 4 times. So your original element would have been shifted to 4 places ahead or in circular direction. So it is 0 1 2 3 4 5 6 7, and now our array is 4 5 6 7 0 1 2 3. So you will see this 0 would have been here, but 0 is now here. So 1 2 3 4, the array is rotated 4 times because 0 is 4 places ahead of its original position. So you just need to find this rotation point. Just need to find the number of rotation, how many times the array is rotated. And how we can get this rotation point? We can get it by the minimum element. We can always get it by the minimum element, because we know that in the original sorted array the minimum element would have been at the 0th index. But if it is at some index other than 0, that means array is rotated that many times. So you just need to find the minimum element to get the rotation point, and then do the basic binary search here in this array. But instead of mid, we'll look for actual mid. And actual mid can be calculated as mid plus number of rotation in circular direction. So how will implement this? Let's try to implement it in a code. First, what we need to find is, we need to find the rotation point. Get rotation, I'll name it as find minimum, because minimum element will give us the rotation point. Find a rotation, let's like this. So we'll have to have vector nums, and then we don't need target here, because we need to find the minimum element, index of the minimum element. So we'll just initialize our low value to be 0, and then high value to be nums dot size -1. Here nums dot size -1, and while low is less than high, we'll calculate the mid equals to low plus high minus low by 2. And what is the condition for finding the minimum element? What was the condition for finding the minimum element? So if you don't have watched the previous video, in previous video I have covered how to find the minimum element in sorted and rotated array. Please go watch that video before continuing to this, so you'll understand how we are calculating the minimum element. So for the minimum element, the condition was nums of mid if it is less than equals to nums of high. So if you don't understood this here, please watch the previous video, because I've already covered this code in the previous video, so I'm not gonna repeat it. So you just need to watch the previous video. So do this. Now we need to search. So this will give, since I'm not returning the minimum element, I'm returning the index. That is why that way we'll have the rotation, number of rotations. So int number of rotations equals to find rotation. Will just pass this array. Just pass this array. So we'll have the rotation point. And after that what I told, we just need to do the basic binary search. So for the basic binary search, what you need to do is, we need to have a low value, that is 0, and we need to have a high value, that is nums dot size -1. Then what you need to do is, while low is less than high, we need to calculate the mid, and int mid equals to low plus high minus low by 2. This will be our mid. But we don't need to compare our target with this mid, because this mid is not the correct mid. We have to get the actual mid. So how we can get the actual mid? Actual mid would be mid plus rotation, number of rotation. This will be our actual mid. See, this will be our actual mid. And since it could be possible that we have to look for the rotation in the circular way, so we have to do it modulo by n, and n is here the size of the array, n equals to nums dot size. Yeah, have to do modulo by n. Okay, now compare with this actual mid. And for the basic binary search, this is very simple. If nums of actual mid is greater than equals to target, then we are reducing our high to mid. Otherwise increase your low value to be mid plus 1. You see, at the end, when low becomes equals to high, then it should point to the first true value. But here, since we are at the time of comparison, we are adding the number of rotations to the mid. That means the low that will be returned by this method, we need to add the number of rotations to that value also. So how we can do is like low equals to low plus number of rotation. This will be the actual low value, number of rotation. Yeah, number of rotation, and we need to modulo it by n because the rotation could be circular, so we need to modulo it by n. I'll just yeah. And at the end we have in a question like if target is present, that means if nums of low equals to target, then we need to return this, otherwise we need to return -1. So let's try to run it. It's accepted. Let's try to submit it. Yeah, it's accepted. So you see here in this question we do not apply binary search directly in the rotated sorted array to search for a target. Instead we find a number of rotations, and while comparing with the mid, we calculate actual mid to be mid plus number of rotation modulo n. So for calculating number of rotation, we need the minimum element, we need the index of minimum element. So we already covered that in the previous video, so we know how to calculate the index of minimum element. So hope you love the concept and hope you get it, and if you get it, then please do like, share and subscribe the channel, and please do not forget to put your valuable feedbacks in the comment section, and see you in the next video. Bye.